We're at go2math.com, working some working some calculus. Let's go down to definite integration. Forgot what I just did actually. I think it was 4-1. Is that what it was? Yeah. Whoa, what is that? 4-2. Find the definite integral. Round to 4 decimal places. I don't know about you, but that looks nasty. So I'm going to write this down. You should be writing it down also. We've got the integral going from 1 to 22, 20 over something, 20 over 8 square roots of x. So we're going to have to rewrite this thing a couple times. 11x to the 1/9 minus 17, and it's all dx times dx. Okay. Got it? Good. I say times dx, this is, back in the olden days, they actually put the dx out here. It was the integral sign dx, and then they wrote the function out. So somehow the function snuck between the integral sign and dx. I'm not exactly sure how that did that, but it did. But this is really just an operator. It says, oh, we need to operate on this thing. All right, so let's do it. What are we doing? Let's go to the whiteboard. Back in the olden days. Back in the golden days. I don't know, did math actually have some golden years? 1 over 22. The golden years of mathematics. When was that? 20 over 8x, 8 square root of x, plus 11x to the 1/9 minus 17 dx, okay? First thing we're going to do here is we're going to go ahead and rewrite this. So we got the integral from 1 to 22, and this becomes x to the half, right? Actually, here's something crazy. We can actually reduce this down a little bit. We got 20 over 8. 20 over 8. Alright, so there's something tricky going on here. And that means that this can be written, you know what, we'll just have to rewrite this several times. So 2 goes, what goes? No, 4. 4, GCD 4. 4 goes into 8. 4 goes into 20. Let's do 4. 4 goes into 8, 2. 5, 5 half, yeah. Okay, so 4 goes into 20 5 times. 4 goes into 8, 2. I'm going to go ahead and rewrite this x to the 1/2 power. Half power, I should say. Plus, nothing we can do here. And then minus 17. Can't do anything there either. Let's put a parentheses around all that and hit it with a dx. Alright. So you probably have already worked it out. Got the answer waiting on me. We have 5x to the negative 1/2. Need to bring that up there so we can take the integral of this thing, just like we do derivatives, right? Plus, nothing here. 1/9 minus 17. Let's put a parentheses around all that, and dx. Okay. Now we can go ahead and take the integral, finally. So we have x to the negative 1/2, so we're going to add 1 to that, so that'll make that actually a positive 1/2, won't it? So 5x to the positive 1/2, negative 1/2 plus 1 is a positive 1/2. Take that 1/2, bring it down here. So we're going to have the 1/2 down here in the denominator, plus 11. We're adding 1 to 1/9. Let's do a little side work up here. 1/9 plus 1. Notice how I do that? That becomes 10/9, doesn't it? 10/9. Another way you can go 9 plus whatever's up here, you get 10. Okay. But, let's do it the right way. And then you got 10 over 9 minus 17x, and we're going from 1 to 22, 1 to 22. And you know what? I'm going to try to, can we sneak this up here so I don't have to change screens? Whatever, maybe we can write it in right up here. Let's do that. Okay, so let's actually clean this thing up first. A half of 2 is 1, right? So we can actually just write that as 5x to the half. All right, looks good. We can take this guy, flip it, so 9 times, that's going to be 99 over 10, which I don't see any of that reducing down. So plus 99 over 10, and that's x to the 10 ninths. Some nice funky numbers. Minus 17x, and remember we're going from 1 to 22. Okay, isn't that a lovely 22? So now we go ahead and plug it in. So we got 5, and you can actually say the square root of 22 here if you want. You know what? I'm going to do that. Square root of 22. How's that? 99 over 10. And I think I'll just do this instead of writing 9 roots of 10, whatever. We'll just do that. Minus 17 times 22. Now remember, this is minus. We'll have to continue this down on this line. Start a parentheses, and then of course we just plug 1 in. So we have 5 times the square root of 1 plus, it's nice to work with ones. They make your life a whole lot easier, don't they? And then you got 1 raised to the 10 ninths minus 17 times 1. Alright, we're going to write an equal. Actually, I'm going to write an approximation symbol here because we're going to be approximating it to 4 decimal places. 4 decimal places. Okay, so I'm going to go ahead and pause the video, get this number. You try to work on that, pause it, and see what you come up with. So I finally got something, and I'm getting a negative 41.39, sorry, 4 decimal places, 39,30786, but that's going to make that a 1 because that's 07. 7 will bump that up to 1 there. So that's what I end up with, negative 41.3931. So we got to hope negative 41.3931, right? Yeah. Hope script is correct and it looks good. I mean, I've checked this several times, but then what I do after I write the script, check it several times with an algebraic calculator, and then when we go back and work this stuff by hand, it's being checked again. So I want to make darn sure there's no mistakes. And if you happen to ever see a mistake, you go right up to the forum up there and let me know, okay? Or there'll be somewhere on this page you can let me know, or you can go to my YouTube channel, whatever. Alright, so we're here at gotomath.com. Gotomath.com. You want to practice. Alright, and I'll see you there.